Question or shall we start? As such?
No, sir, I'll give two lines introduction, sir.
Sure, sure.
Yes, please. Good morning to one and all present here. Welcome to the day 2 of UGC sponsored national level CSIR GORF net workshop. May I now request Dr. A.L. Muthukumar, sir, to take over the session?
Yeah. Thank you, Sushmita, for that introduction. And I welcome you all to the second session of the day 2 of national level UGC CSIR net workshop. Okay, I would like to share my screen. So make sure the screen is visible to you.
Yes, sir.
And so screen is visible.
Yes,
Yes,
sir,
sir.
visible, sir.
Yeah, thank you so much. Fine. So in today's session, I'm going to discuss the second part of this problem solving approach in heterocyclic chemistry. Okay, fine. So in the last session, I have discussed the preparation of whatever the heterocyclic compounds like pyrrole, furan, and thiophene, and after which we have discussed some of the reactions of furan-based reactions in this heterocyclic chemistry topic. So in today's class, I'm going to discuss the remaining part of that five-member heterocyclic preparation method. That is the reactions of what is it, the thiophene, reactions of pyrrole, and the reactions of indole, and reactions of pyridine. So this kind of molecules I'm going to discuss. Okay, let me start. Fine. So first reaction is, that is nitration of thiophene. Already we have discussed this reaction, basic mechanism I have discussed. That is, this thiophene has to be treated with this acetyl nitrite. So as a result of this, you will be introducing the nitro group. So very simple reaction. So this will be attacking here. This nitro group, it will be attacking here, and this group will be leaving. As a result, the nitration is taking place at that C2 position of this thiophene molecule. Fine. So next reaction is that is halogenation of thiophene. So this is somewhat important. Keep in mind. So if you treat this thiophene molecule and with the bromine along with that 48% of HBr, and the temperature is minus 25 to 5 minus 5 degrees centigrade. And if you do that, bromination is taking place at C2 position of this thiophene. Suppose if I do the same bromination, the same bromine and diethyl ether as a solvent, along with that 48% of HBr, and if you increase the temperature, you can see the temperature that is minus 10 to 10 degree, plus 10 degree. That means you are increasing the temperature. So the increasing temperature will lead to the formation of dibromothiophenol. I already discussed in that the last session that in five-member heterocyclic system, the C2 position and C5 positions are always more reactive. So once the first reaction will be taking place at C2 position and the second bromination is taking place at C5 position. That means when you increase the temperature, it leads to the formation of the second bromination also at C5 position. So this is what important in this case. That means this reaction is purely temperature oriented. Next one. So given you a CSR question. This was the last CSR, whatever we people might have written. So this CSR question involves that 3-methyl thiophene is treated with NBS. That is, then you have the corresponding benzoyl peroxide, and this is solvent. And if you heat it, what will be the reaction? Okay. So most of you people, you might have thinking that this reaction is taking place at the ring of this thiophene molecule. Actually, that is not taking place here. So you have to be very careful in answering this question. So actually, suppose if we are having only thiophene, and this thiophene is treated with NBS. NBS structure is, that is N-bromosuccinimide. So this is a structure of NBS. Okay, so when you treat this thiophene with NBS, obviously the reaction is taking place at C2 position. Okay, so if the reaction is taking place at C2 position, you will be getting 2-bromothiophenol. But here they are not giving only NBS, they are giving, this is benzoyl peroxide. Actually, this is a radical process. Actually, it's a very good radical initiator. That means in this case, you might have studied in your BSc itself this reaction. That is, when you treat toluene with NBS, in the presence of some peroxide, and it will lead to the formation of benzyl bromide as a product. So you might have studied this reaction in your BSc itself. Okay, so this simple bromination of this benzylic hydrogen will be replaced by this bromine atom. So this reaction only happening here. Okay, so this is actually a 2-mark question. Most of you people might be thinking that the reaction will take place at the ring, but it is not the case actually. Okay, so let me explain the mechanism of this reaction. The first step is the chain in radical initiation will be there. So this is an initiation process. So in this initiation process, if you check with the mechanism, so this is benzoyl peroxide. When you heat this compound, it gets cleaved homolytically. So that means it produces the corresponding radical. Okay, so 2 moles of this radical will be produced. Now what happens next will be like the CH3 of this 2-methyl thiophene will be reacting with this radical. Okay, so this radical takes this hydrogen atom, which is labile in nature. So why it is taking this hydrogen, sir? If you ask the question, so this radical can be stabilized by resonance effect. So CH2 radical will be forming, means it can be stabilized by resonance effect. So that is why this hydrogen is replacing instead of this ring hydrogen. The ring hydrogen, if a radical is formed, means it is not stabilized by resonance effect. That is why it is forming at this position. That means it is resonance stabilized. Okay, so now what happens here? So next step will be like propagation. So what is happening here? Now this radical species will be reacting with NBS. So what is happening? It takes this hydrogen atom, takes this bromine radical here, and then succinimidate radical will be formed. So as a result, you will be getting the formation of the corresponding bromo substituted product. That means the option 2 is the right answer. I'm not going the mechanism in detail, just I'm giving you how to solve the question. Okay, so don't think that always NBS means ring bromination will be taking place. Suppose if they are giving this peroxide, means you have to be very careful, so that whatever the labile benzyl hydrogen will be undergoing the bromination reaction. Okay, fine. We'll go to the next question. Actually, this question was asked in December 2018 CSR. Actually, this is a 4-mark question. The important thing is the reaction is not taking place in the ring. Okay, but since it is a thiophene molecule, it is a heterocyclic compound. I would like to discuss this question with you all. Fine. So you have taken that. Sorry for the poor clarity. Actually, if you check with the previous year CSR question official website, they have given this type of clarity only. So please bear with this. Actually, what is happening in this reaction is that you are taking this 2-acetyl thiophene. Okay, so I'm just giving you the exact mechanism of this reaction. Actually, the right answer is option 3. Let me solve this question. Actually, if you check with the third option, the first step is formaldehyde and dimethylamine. They are reacting in the presence of HCl. So I have already discussed you in the previous class. That is, when you treat formaldehyde and dimethylamine in the presence of acid, it will provide you a formation of iminium ion. That is manic reaction, I have already said. So by the removal of water, it will be leading to the formation of the corresponding iminium ion. That means you can write that CH2 double bond N Me 2 times. Actually, this is what happening in this step, and what is happening here? This compound followed by the treatment with sodium hydroxide. Sodium hydroxide is a base. So what happens here is, so this base is abstracting this hydrogen atom, and it provides you the corresponding anion, because this hydrogen is acidic in nature, because this methyl group is connected to C double bond, which is an electron withdrawing group. So now what happens here? Now this CS2 minus will be attacking this CS2, and this electron will be shifting here. Okay, so as a result, it will lead to the formation of the corresponding manic type of reaction. It is not star-kinamine, it is like manic type of reaction. That is, you will be getting CS2, CH2, and you have this NMe 2 times. Okay, so next step is this compound has to be treated with sodium borohydride. Sodium borohydride is a reducing agent and it reduces the C double bond O. We know that when a ketone is reduced by any reducing reagent, it will be converted into a secondary alcohol. Now this is converted into a secondary alcohol. Okay, so now you have CH2, and you have NMe 2 times. Now the final step is this alcohol is treated with sodium hydride. So if you use sodium hydride, it will be acting as a base. So it takes this acidic hydrogen atom and it provides you the corresponding anion. So you have O minus here, CH2 and NMe2 here. Okay, so now this compound is treated with 1-fluoronaphthalene. That is, the whatever reaction is taking place, if you ask, that is simple SNAR type reaction. That is, it is attacking here, this fluorine will be knocked off and you will get the corresponding product. So this is a target molecule that they have given here. You can cross check with this. So that means, so even though the reaction is not taking place at the heterocyclic ring, but this reaction is very easy. An MSc student can answer this question very easily, I believe so. Okay, so with this we have completed the thiophene and the reactions of thiophene. Next we'll go to the reactions of pyrrole ring. So the simple reaction that when pyrrole is treated with acetyl nitrate at minus 10 degrees centigrade, and it will provide you, that is 51% of 2-nitro pyrrole. Okay, so now next to reactions of these all reactions we have already discussed with the mechanism in the previous session. So if you have any doubts, you can use that YouTube link and you check with the previous whatever the mechanism we have discussed. Okay, next thing is Wills-Mayer formulation of furan. I have already discussed this mechanism also. So this Wills-Mayer reaction introducing the formyl group, that is aldehyde group, will be introduced, and the most reactive position of this pyrrole ring is, that is second position. The second group position, aldehyde group is introduced, and you are getting 83% of this product. Okay, fine. Next reaction, what I'm going to discuss is, this reaction is very much important. There are 2 times CSR questions who are asked. Okay, so not exactly the same molecule. I mean, with the different molecule, they have asked a question. So keep in mind, this reaction is known as siamicin dense tetrate reaction. So this reaction involves the reaction of pyrrole with sodium hydroxide followed by in chloroform will give you 3-chloropyridine as a final product. Let me explain the mechanism of this siamicin dense tetrate reaction. So you might have studied in your +2 itself, that is Remer-Tiemann reaction. So in that case, the formation of dichlorocarbon will be taking place when there is a reaction between chloroform and sodium hydroxide. Exactly the same reaction is happening here. So initially this chloroform is having this acidic hydrogen. So OH minus, that is NaOH produces OH minus. So this is acting as a base and it abstracts this acidic hydrogen atom, and water molecule will be removed. As a result of this, you will get the corresponding anion. Okay, from this anion, this Cl minus will be removed. So this is known as alpha elimination. Okay, so this alpha elimination will provide you a carbene known as, that is dichlorocarbene. So this dichlorocarbene is active species in this siamicin dense tetrate reaction. So what happens here? Parallelly, what is happening? This sodium hydroxide also deprotonates this acidic hydrogen of this pyrrole. So this hydrogen will be removed and you will get the corresponding anion. So this anion is formed here. Now what is happening? So this is attacking here and this electron will be moving here. So you might have studied in your MSc itself, BSc itself, that is a Siemens-Smith mechanism, a reaction. So when an alkene is treated with a carbene system, so this will be forming the corresponding cyclopropane as a product. So this is a well-known reaction. So that reaction only is taking place here. So as a result of this, you can see the formation of cyclopropane is taking place now. What is happening here? That cyclopropane is highly strained ring system, which is having two leaving group halogen atoms. So what is happening? This electron is coming here, and this carbon-carbon bond is broken here, and it is moving here. Okay. As a result of this, you can see here the Cl minus will be leaving. So it will be leading to the formation of this product. So you can see here the bond between this carbon is broken here, and it is moving here. Okay, fine. So if you draw the compound properly, it will be leading to the formation of the trichloropyridine as a product. So it is an important reaction, just keep in mind. So these are the important reactions of the molecules, that is pyrrole. So now I'd like to discuss a few CSR questions based on pyrrole as a reactant. So I think this question anyone can answer. So easy question. So let me explain the question. What is happening here is that is N-methyl pyrrole is treated with formaldehyde and dimethylamine. So I have already said this will be leading to the formation of iminium ion, that is manic base. So the first step is simple manic type of reaction. So this iminium ion is reacting with this N-methyl pyrrole. So what is happening is this C2 position will be attacking here, and this electron will be shifting here. It will be leading to the formation of this product. So this is a product number A. So this is CH2 N Me 2 times. Okay, I hope you got the mechanism. Okay, so this is A. Now this compound is initially treated with methyl iodide. So what is happening here? This is a tertiary amine. Now this is having lone pair of electron. So this lone pair of electron attacks this methyl group. As a result, I will be leaving as I minus. Like it will be leading to the formation of a quaternary ammonium salt. So CH2 Me 3 times. So now this becomes a very good leaving group. So what is happening here? This lone pair electron will be coming here, and this electron will be moving here, and this electron will be pushing here, and this group will be leaving. So here trimethylamine will be leaving. So leading to the formation of this intermediate. So here you have CH2 group. Sorry. So here you have a double bond. Here you have double bond. Since this nitrogen has donated a pair of electron, a positive charge is generated. And if you check with the last step, they are using sodium cyanide. Sodium cyanide will be separated as Na plus and Cn minus. So this Cn minus attacking this CS2 group, and this pi bond electron will be moving here, and this electron will be moving here, and this will be leading to the formation of the final product. CH3, you have double bond here, you have double bond here, you have CH2 Cl. So if you check with the option that is option, I think option 2 is the right answer to this question. That's it. I think this question is a 4-mark question. Can you imagine how easily they have asked this question in the CSR examination? Fine. We'll go to the next example. So I think this question also asked in CSR examination. I think this is a 4-mark question. So what is happening here? That is N protected. BOC means tertiary butoxy carbonyl. It is a protecting group. Okay. So let me explain the BOC. So BOC means it is a protecting group of amine. So that is tertiary butoxy carbonyl. So this is used as amine protecting group. Okay, fine. So what is happening in the initial step that, so this N BOC protected pyrrole is treated with the corresponding alkyne compound. That is, you have triple bond, and which is connected to a sulfone group, that is SO2 phenate. So you can see this molecule in the following manner. So you can see here, yesterday we have discussed a lot of reactions of heterocyclic compounds in Diels-Alder reactions. So you can see this is acting as a diene system, and this will be acting as a dienophile. So a simple 4+2 cycloaddition, that is Diels-Alder reaction, is taking place. So what is happening here? This electron is attacking here. I'm sorry. So this electron is moving here, and this will be moving over here, and this double bond will be shifting here. As a result of this, you will be getting N BOC and this triple bond becomes double bond here, that is SO2 phenyl, and there is a bond between these two carbon atoms. Okay, so you have a double bond here. So if you draw the double bond, I mean this compound properly, so this is like a bridged system. So in which a double bond will be here and double bond will be here, and this will be having protected with bond. Okay, so now here you have SO2 phenyl. Now this compound is treated with this. You can find out option 1 and 2 are ruled out. Option 3, 4 can be the answer. So this compound is treated with hydrogen in the presence of palladium carbon, and it will be leading to the formation of reduced product. Now you have two kinds of double bond where the reaction will be taking place. That is a question. So you can see here, this is a less substituted double bond, that is less hindered double bond, and this double bond is more hindered double bond. So the reactions will be preferred at less hindered double bond, that is less substituted double bond will be reduced selectively over the more substituted double bond. So as a result of this, this alkene will be converted, the left side alkene will be converted into corresponding alkene, and this alkene remains intact. So what you will get the corresponding product. And if you check with the option, that is option 3 is the right answer to the question. I think this question is somewhat difficult in the second step, so that I have given you the explanation to this question. Fine. We'll go to the next molecule, that is synthesis of indole. So we have completed with the 5-member monocyclic heterocyclic compound. Then we are going to the benzofused heterocyclic compound. The first compound is indole. A well-known and important reaction, that is Fischer-indole synthesis. So this is very famous reaction. So you have to take phenyl hydrogen as a reactant. Okay, so this phenyl hydrogen will be reacting with the corresponding ketone. So we know that there is a presence of an amine, and you have a C double bond O, the removal of water molecule will be taking place. You can check here, and it will be leading to the formation of a species known as hydrazone. So this hydrazone is treated with Lewis acid or Bronsted acid with the elimination of ammonia will be leading to the formation of substituted indole. So let me explain how this step, that is second step, is taking place in the upcoming reaction. You can check here. So this is a hydrazone, whatever we have discussed here. So you have an imine functional group here. I have already said, when you have a imine, and if you have any alpha hydrogen, so whenever imine is having alpha hydrogen, then immediately enamine will be formed. So you can see here, so there is a formation of double bond over here, and this hydrogen is shifting towards this nitrogen atom, and you can check there is a formation of imine. Now if you check with this particular skeleton, so this will be reminding you this reaction, that is Cope rearrangement. In pericyclic reaction, you might have studied this rearrangement, that is Cope rearrangement, in which this electron will be shifting, this electron will be shifting, this electron will be shifting. As a result, you will get this product. That is, it is a 3,3 sigmatropic rearrangement. This is known as Cope rearrangement. Okay, that is the exact reaction is taking place. You can see here. So initially, what is happening? This nitrogen will be protonated, and it will form the corresponding ammonium ion. And in this case, so the exactly like Cope type of rearrangement is taking place. You can check with the skeleton. What is happening here? So first step, this electron will be shifting here. So this is the first step. And second step, this bond will be shifted over here, and this nitrogen-nitrogen bond will be broken. That is the third step. That is the 3,3 sigmatropic rearrangement is taking place, and it will be leading to the formation of an imine system. So now, in order to get this benzene ring becoming aromatic in nature, so what is happening? This hydrogen will be coming here, and this is taking this H plus, which is being utilized as a catalyst. You can check with the main reaction. H plus or Lewis acid has to be used. So that is what happening here. This H plus is taking here. So what is happening here? H plus will be removed. That is, the catalyst has been removed here. So it forms a corresponding amine. That is, aniline ring is back. So in parallelly, what is happening? This hydrogen will be going and attacking this NH group, becomes NH2 plus here. So now, what is happening here? This nitrogen lone pair is attacking this carbon of C and double bond. As a result of this, this electron will be shifting over here, and this NH2 becomes neutral in nature. Parallelly, what is happening? So this NH2 will be reacting with this H plus. So NH2 becomes NH3. Now it has become a very good leaving group. And finally, this catalyst has to be regenerated. No. So what is for the purpose? This hydrogen is coming here, and this will be leaving as ammonia. So you can check here the formation of substituted indole has come here. Okay, so this is an important reaction. Please keep in mind. So you can expect in upcoming CSR examination or GATE examination. Okay, fine. We'll go to the next reaction. I think this is another important reaction, that is reset indole synthesis. So the reset indole synthesis, the reactant you have to take, that is 2-nitrotoluene or orthonitropoluene as a reactant, and you have to take, that is diethyl oxalate as a reagent here, a reactant here, and along with that sodium ethoxide base has to be used. So initially what is happening, let me explain the mechanism here. So sodium ethoxide is a base. So what is happening here? You have a methyl group. So this is taking this acidic hydrogen, because this methyl group, adjacent to the methyl group, you have a nitro group, that is an electron withdrawing group. Whenever an electron withdrawing group is present, that the ortho position, this hydrogen will be more acidic in nature. So as a result of this, this takes this hydrogen, acidic hydrogen, from methyl group, and it will be leaving as ethanol, leading to the formation of the corresponding anion. So you have CH2 minus here, and you have a NO2 group here. Now this is reacting with this diethyl oxalate. So this minus charge will be attacking here. This OET group will be leaving and leading to the formation of this intermediate. That is why I have given here. So let me explain the complete mechanism here. So CH2, you have a C double bond O, you have a C double bond O, OET. So that is what I have given here. So here you have a NO2 group. Now what is happening? This compound is treated with zinc acetic acid. So you might know that whenever a metal is added to acid, or acid is added to metal, what is happening here? Liberation of hydrogen will be taking place. Now, so the liberation of hydrogen will be leading to the conversion of this nitro group into amine. So whenever you have a nitro, and if you want to convert an amine, so generally you will be taking with metal with an acid. So very famous reagent, that is tin HCl, some people might be using for the conversion, and here they have given zinc acetic acid and metal combination they have given. Okay, so as a result of this, let me draw here. So as a result of this, this nitro group will be converted into corresponding amine. You have a CS2 group, you have C double bond O, you have C double bond O OET group. Okay, so next step will be like, so this is an amine, and this is C double bond O. Simply I'm writing the mechanism. I'm not giving the complete explanation here, because we have plenty of things to discuss. So what is happening? N double bond C will be forming, and here you have C double bond O OET. So that means here water molecule will be leaving. Now finally, in acid condition, what is happening here? This catalyst is regenerating. And you are getting back this indole. So parallelly, what is happening? This is an acid condition, the reaction is taking place. Okay. So meanwhile, what is happening? This ester group is hydrolyzed under acid condition to the corresponding carboxylic acid. So the ester group is converted into carboxylic acid during the course of the process. That is hydrolysis of ester under acid medium that is taking place. So you can check with the product. So this is a product. And if you heat this compound, you can check with the basic reaction at the top. So what is happening here? The removal of carbon dioxide is taking place. At the top I am writing. So the removal of carbon dioxide will be leading to the formation of indole. So this is reset indole synthesis, one of the important reactions of synthesis of indole. There are plenty of things are known, but I'm giving only a few. Okay. Next thing is the reactions of indole. So if you want to give the numbering of indole, that you need to start from 1, 2, 3, and 4, 5, 6, 7, 8, 9 will be there. Okay. So there are two rings in indole. The one ring is benzene ring. So other ring is pyrrole ring. So you might have seen in the previous session, I have explained you the reactivity of benzene and pyrrole and thiophene or furan kind of heterocyclic ring system. So I already said that the reactions of benzene towards electrophilic substitution will be less. So when you compare these two rings, this ring will be undergoing predominantly over this ring. It doesn't mean that the benzene ring will not undergo reaction, but thing is the pyrrole ring system is more reactive than the benzene ring system. That is what you need to know. Now the question is, in pyrrole ring there are two positions, that is C2 position and C3 position, where the reaction will be taking place. That is a question. For example, let us take this reaction is taking place at C3 position of indole ring system. So the electrophile is approaching at the C3 position. As a result of this, the C2 position will be having the positive charge. Once this cation is formed, you need to know the stabilization of the cation by any means. By any means means generally resonance effect. So this cation is stabilized by this nitrogen lone pair, and as a result of this resonating structure is formed. Okay, so now as a result of finally what is happening, this H plus will be leaving, and as a result of this you will get C3 substituted electrophile substituted product. Okay, now there is another possibility, why not the reaction can take place at C2 position? You might be asking the question. So if the reaction is taking place at C2 position means, so instead of VX you can keep nitrogen, NH you can keep. So what is happening, the reaction is taking place at C2 position. So if C2 position the electrophile is approaching, C3 position will be getting positive charge. Now this cation has to be generated, that is without disturbing the aromaticity of benzene ring, I'm unable to draw any resonance structure. Whereas in the case of C2 position attack, without disturbing the aromaticity of benzene ring, I'm able to write at least one resonating form. So in this case, I cannot write any resonating form without disturbing the benzene ring. So as a result of this, the benzene aromaticity has to be disturbed. Okay, so here because of this formation of this cation, the aromaticity of benzene is disturbed, and in the previous case the benzene aromaticity is not disturbed. Without that, we are able to write the corresponding resonating structure. So as a result of this, the C3 position of indole will be more reactive than the C2 position of indole. So that is a conclusion here. Suppose if C3 is blocked, you may expect a reaction at C2 position. Then C2 reaction may take place. Okay, so this is an important thing that you may be knowing. Then another important thing is, if in some cases the benzene ring also will be undergoing electrophilic substitution. Say for example, if you consider this benzene ring, this system alone, so you just imagine whatever that I am highlighting, you can imagine like this is an aniline system. So this aniline, if you consider this benzene ring, it is looking like aniline system. So this nitrogen will be acting as ortho-para director in aniline. You might be studying, might have been studying in your BSc, +2 itself, ortho-para directing group. Okay, so when compared with ortho position, that is steric hindrance in nature. So instead of ortho position, the reaction will be taking place at the para position. So if you check here, so to this nitrogen atom, this is ortho position, these two are, these two are ortho position, and these two are meta position, and this position is para position. So if some cases the para to this nitrogen of this benzene ring will be undergoing electrophilic substitution, so that also you have to keep in mind. So this is an important thing. Okay, fine. So let me go to the reactions of indole. Say for example, in this case, if you check this compound, that is 2-methyl indole is treated with benzoyl as a benzoyl nitrate at 0 degree centigrade, that C3 position of indole will be undergoing a reaction. So that means the nitration is taking place here. So here also, if you treat this compound with concentrated nitric and concentrated sulfuric acid, I already said this is this concentrated nitric and acid and concentrated sulfuric acid we generally use for the nitration of benzene substituted compound only. Okay, so in this case you can check here, this nitration is taking place at the benzene ring, and you know that this is an ortho para director, this nitrogen atom, and the reaction is taking place. This is ortho position, this is meta position, and this is para position. So the reaction is selectively taking place at the para to this nitrogen atom. That is, benzene ring will be undergoing reaction. So this reaction is important. Just keep in mind. Okay. So now what is happening here is that the polymerization occurs when there is no substituent at C2 position. That means it is highly reactive in nature. So if you don't protect at the C2 position, means the polymerization reaction will be taking place. Okay, okay, fine. So next example, that is manic reaction. So we know already that this reaction of formaldehyde and secondary amine will be providing you an iminium ion, which is known as the manic base. Okay, so we know that the reactivity of pyrrole ring will be happening at C3 position. So the C3 position will be attacked here, and you will get the corresponding substituted product. So this is very simple reaction. Now, so once this is formed, the name of this compound is gramine. Now this gramine is treated with methyl iodide. Same reaction just before I have explained in the case of CSIR examination. Same thing is happening, that it will be leading to the formation of quaternary ammonium salt. So that is what's taking place here. You can check here, there is a formation of quaternary ammonium salt. So this quaternary ammonium salt will be reactive with sodium cyanide. So initially what is happening, this lone pair will be pushed here. Okay, so this electron will be shifting here, and this is a very good leaving group, this is leaving here, leading to the formation of this type of intermediate. Now what is happening, the Cl minus is coming in the next step, and the Cl minus is attacking the CS2 group. This electron is coming back, and this will be taking in the proton from water molecule, leading to the formation of the cyano-substituted product. So simple substitution reaction is taking place at another important reaction. Same kind of reaction just before we have discussed from CSIR examination. That question was a 4-mark question. Fine. Now let us discuss some CSIR based questions which involves indole as a product as a reactant. Okay. So you may be seeing this reaction just before we have discussed. You can check here. So this reaction is the same reaction, that is what they have asked. That is the recent indole synthesis. Same reaction, exact same reaction they have asked in the CSIR examination. That is, I think the year is 2013. Okay. There is no change in that question. Just they are taking that is 2-nitrotoluene, which is treated with the diethyl oxalate in the presence of sodium ethoxide, followed by the treatment with zinc acetic acid. What would be the final product? So I have already discussed the same question. So if you check with the thing, initially this will be formed, and after that formation of indole will be taking place. That is option A is the right answer. And can you imagine, this is a 4-mark question? How easily they are asking the question, you can see. Fine. So next example is this one. That is the major product formed in the following reaction. So you may be knowing that this is DMF, and this is POCl3. When you treat the DMF and POCl3, that means the reaction is Wills-Mayer reaction. So you may be already knowing this reaction. The Wills-Mayer reaction involves the introduction of aldehyde group. So we know that which is the most reactive position of indole. That is C3 position is the most reactive position of indole. Just an aldehyde group is introduced at the C3 position. Can you say what is the right answer? That is option 1 is the right answer. Straightforward 2-mark question. Okay. We have one more question. I think this is a 4-mark question. Recent CSIR, that is 2019 CSIR, they have asked the question. So actually this question is a little tricky one. You can see that the major product A and B of the following reaction sequence. So this compound contains indole ring, and in the same time this compound also contains furan ring. So now which is more reactive? That is a question. You can check with the first step. The first step, what is happening? DM of POCl3, one equivalent they are using. That means only one time you can introduce the aldehyde functional group. Now the question is where the reaction, which molecule will be undergoing reaction. So I've already explained you that. So indole is similar to that of pyrrole system. If you compare the reactivity of pyrrole and furan, which is more reactive, that is pyrrole is more reactive than the furan molecule. So that is what happening here. So this reaction, the first step, this is what taking place. This is a more reactive ring system. And this is less reactive ring system. Okay, so if you check with the reaction, that is the more reactive will be undergoing first when you use only one equivalent of POCl3, and where the reaction is taking place, that is the second question. So we know that just before we have discussed that in the indole, that is C3 position is more reactive. So in the first case, C3 position introduction of aldehyde will be taking place. Can you check which is the right answer? So if from that first step you can say that is option 3 or option 4 can be the right answer, where the C3 position of indole will be introduced by this formyl group. Okay, that means option 1 and option 2 are ruled out. Now the second question is, when you use excess of POCl3, that means the second reaction is also taking place in this case. Second reaction means where that aldehyde group will be introduced. I already said in the case of furan, that is C2 position will be more reactive. Okay, if C2 is blocked, you may be immediately thinking of the reaction will maybe taking place at C5 position. Now the C2 position of this, furan is blocked. Now you can expect the introduction of this aldehyde group at C5 position. So with that, which can be the right answer? That is option 4 is the right answer to this question. So you can see, imagine that this is a 4-mark question which is asked in CSR examination. Okay, fine. We'll go to the next one. That is, this is also a CSR question. This reaction is based on siamicin dense tether rearrangement. So just before I have explained the mechanism of this siamicin dense tether rearrangement with pyrrole as a reactant. Now they have asked indole as a reactant. They have used the same scheme only. Same reagent is used here. So initially, what happens here? We have already known that. So when chloroform will be reacting with the sodium hydroxide, it provides you the corresponding anion. Now, in which alpha elimination will be taking place, it will be leading to the formation of this carbene, dichlorocarbene. So that is what the initial step. And parallelly, what happens? This hydrogen of this H group is removed by this base. So what happens? It provides you the corresponding anion. Now this anion is reacting with this dichlorocarbene system. So I have already explained you that is the formation of cyclopropane ring will be taking place. So here you have a methyl group, here also you have a methyl group. So here cyclopropane ring, you have a Cl group, here you have a Cl group, and you have methyl group here, and you have one more methyl group here. So now this anion will be coming here. So this carbon-carbon bond will be broken here, and this Cl minus will be leaving. So what you have to draw as such. First you draw as such. Whenever the rearrangement reaction you are reading means you have to draw the skeleton as such. That means I'm drawing this as such, like in the previous step. Okay, so what happens here? There is a formation of a double bond. As a result of this bond is broken, and here the formation of double bond is taking place, and Cl will be leaving as Cl minus. So this part will be leaving. Now, if I draw this compound properly, you have this corresponding quinoline ring, and the second position you have a methyl group, third position you have a chlorine atom, and fourth position you have another methyl group. So this is a final product. So the question they are asked is, what is the intermediate involved and what is the major product involved in this reaction? So I already explained the intermediate will be like dichlorocarbon will be the intermediate, and the major product will be this product. So can you find out the right answer? That is option D is the right answer to this question. Okay, fine. I think this question also asked in a 4-mark question. Next question is, this is another question, that is this question was asked in June 2016 CSR examination. Okay, so the question is, you have an alcohol which is connected to the third position of this indole ring. Now this is treated with the BF3, which will be acting as a Lewis acid. So what happens here? So this will be coordinating, the lone pair of oxygen will be coordinating with BF3, which is a Lewis acid. As a result of this, the formation of this complex will be generated. So what happens here? N, you have hydrogen atom, you have a double bond, CH2, you have CS2, you have one more CS2, you have one more CS2, you have more hydrogen, and this here you have BF3 complex. So here you have minus, since it accepts a pair of electron. Here you have a positive charge on oxygen atom since it donates a pair of electron. Now, what is happening here? Here you have isotopic labeled carbon, that is C14 isotopic labeled carbon. What happens here? We know already the third position of indole will be more reactive. So what happens here? This electron is coming here, and this electron will be going and attacking the CS2 group, and as a result of this, this group will be leaving. So as a result, how many ring will be formed? You can cross check. That is 1, 2, 3, 4, 5. There is a formation of 5-member ring at the third position. That is, it will be leading to the formation of a spiro kind of compound. You have hydrogen atom here, double bond. Here you have 5-member spiro compound. So here you have isotopic labeled carbon. So this is 1, you can check 2, 3, 4, 5. That is what I have written here. So you can also draw, since this nitrogen has donated a pair of electron, a positive charge is generated. So you can also draw in this fashion also. So both are correct. So in this case, you are just giving the number in this fashion. That is 1, 2, 3, 4, 5. Okay. So in that way, you can draw this compound in 2 ways. So in the first way, what is happening? So this bond electron is migrating here and attacking the C2 position of this indole ring system. This electron is moving over here, which will be leading to the formation of a 6-member ring. So you can check this electron will be here. So you have isotopic labeled carbon. This is 1, 2, and you have third position, you have one more CS2. Fourth position, you have one more CS2. And the fifth position, you have one more CS2. This fifth position CS2 is directly attacking to this ring system. Now a positive charge is generated, and elimination of this hydrogen will be leading to the corresponding product. That is, indole ring will be generated. Okay. Now you can check with the second case. There is another possibility because these two are symmetrical in nature. Okay, so you have another possibility. When C5 is reacting here, there is a possibility of this isotopic labeled carbon migration also. So in the first step, the C2, the simple non-isotopic carbon has migrated. In the second step, the isotopic labeled carbon will be undergoing migration. What happens here? This bond electron will be coming here. So this electron will be shifting here, and as a result, it will lead to the formation of this isotopic labeled migrated carbon labeled migrated part. That is, you have fifth carbon, this is fourth one, you have a third one on CS2, and second one you have isotopic labeled carbon which is connected to this carbon. So you have this one. So since this electron has come here, there is a generation of positive charge, and finally the removal of H plus will be leading to the formation of the final product. Okay, fine. So the question is, what are the products that can be found? You can check with the answers that you can check here. That is Isotopic migrated carbon also there is a product formation, and this non-isotopic migration of carbon also will be occurring. So that means you will be getting a mixture of product. That is option 3 is the right answer. So you can cross check with the products. So these are the products that I would like to discuss. Okay. Another important reactions, simple like Fiddlecraft type of reaction you may be thinking. Okay, fine. Next reaction is that is synthesis of pyridine. So we have almost completed that. What is that? That 5-member fused ring system. Next thing is that is pyridine molecule. What are the synthetic method? What are the reactions that are involving in pyridine ring system? That is what very much important in terms of both the CSR as well as in gate examination. That is one important synthesis of pyridine. That is Hans pyridine synthesis. So it's a well-known reaction, and it is very much important both in the case of CSAR as well as in the gate examination. Okay, so you have to take 2 moles of this active methylene compound. This is active methylene species. The name of the compound is that is acetyl acetone. You have to take 2 moles of this acetyl acetone. You can take this 2 moles. So initially, what happens? So here you have an aldehyde group. So here you have benzaldehyde. So we know that aldol condensation, when you have and CS2 group is there, which is active in nature, COCH3. Here you have COCH3. Aldol or Navanagal type of reaction, anyway you can call it as. So here you have benzaldehyde. In the presence of base, just removal of simple water molecule will be taking place. You have a double bond here, you have a phenyl group, you have hydrogen. That means the formation of an alkene will be taking place. That is what happening here. You can check here. So you have this here hydrogen atom, you have oxygen atom. And initially, a simple aldol condensation is taking place by the removal of water. You can check with the pH, that is pH 8.5, that is basic condition. At basic condition, the aldol type of condensation followed by the rearrangement, dehydration is taking place, leading to the formation of a double bond system. Now, if you check here, this is an alpha beta unsaturated carbonyl compound. Parallelly, what is happening? So this acetyhydrogen, in the last class itself, I have explained that whenever you have an active methylene species, this hydrogen will be more acidic in nature. So meanwhile, what is happening? This base deprotonates this acidic hydrogen atom, and it provides you the corresponding anion here. Okay. Now this anion will be added like Michael type of addition. Michael type of addition means that is 1,4 addition, 1, 2, 3, 4 addition. So this is simple Michael type of addition which is taking place here. So what is happening? This electron is moving over here and attacking the 4th position, and this electron will be shifting here, and this electron will be moving towards oxygen atom. So you can check here, there is a formation of carbon-carbon bond, and it provides you the corresponding intermediate. So let me draw the intermediate initially. So this will be giving you a double bond here. O minus will be there. You have a methyl group. You have phenyl group. Here you have a CH2. Here you have C double bond O Me. And here you have a C double bond O Me. Okay. So now this is like an enolate form. So if it tautomerizes, it will be giving you the corresponding keto form. So you can cross check here. Now the keto form will be formed. That means this part will be generated, converted into this part. Okay, so the enolate will be converted into the corresponding keto. Now parallelly, what is happening? This is reacting with ammonia. So I already explained that the removal of water will be taking place when you have ketone and amine. So that is what taking place here. So it will be initially forming an imine system, and followed by that, if you have alpha hydrogen, it will be leading to the formation of enamine. So that is what taking place in this step. You can check here, the enamine formation is taking place. Okay, fine. Next step is this nitrogen lone pair is attacking this oxygen atom of, carbon atom of C double bond O, and as a result of this, this electron is moving towards oxygen atom. You can see here there is a formation of this corresponding intermediate. So here you have NH hydrogen atom. You have already a double bond here, methyl group, C double bond O, Me group. Here you have hydrogen. Here you have phenyl group. Here you have C double bond O, Me group, and this side you have O minus. Fine. So this nitrogen will be having positive charge since it donates a pair of electron, and this oxygen atom having a negative charge since this pi electron has moved towards this oxygen atom. Okay. So now what is happening? Proton transfer is taking place. This O minus becomes OH. So here you have OH group. Here you have a keto group, hydrogen, phenyl. Here you have C double bond O, that is keto group is there. Here you have methyl group. Okay, so here already you have a methyl group, missed it. Now what is happening? A removal of water will be taking place in this step, and it will be leading to the formation of this intermediate. That is what I have given here. So here the removal of water is taking place. So as a result of this, the double bond is formed. Now, if you treat this compound into with nitric acid, nitric acid is an oxidizing agent. So oxidation process means that is removal of electron is called oxidation. Otherwise, removal of hydrogen is called oxidation. Addition of oxygen is also called oxidation. So in this case, the compound has to get aromatization. Okay. For that purpose, the removal of hydrogen is taking place. You can check here in this step. That is, removal of hydrogen is taking place here. So this electron will be coming, this will be coming, and this will be leaving. Okay. So as a result of this, you will be getting the corresponding pyridine as a product. So this reaction is so important. Please keep in mind. So you can anytime you can expect in upcoming CSR examination. Okay. Fine. I would like to go to the reaction part of this pyridine. Pyridine has it is a peculiar compound when it reacts with an electrophilic aromatic substitution. So what is the thing that is happening? So when pyridine is introduced into with an electrophile. Electrophile means it is like the basic definition of electrophile, that is electron liking species. Okay, so it needs electron. Pyridine has nitrogen atom which contains a lone pair of electron which is free in nature. So immediately what happens, it coordinates with this electrophile and it forms a corresponding pyridinium ion. Okay, now this pyridinium ion, once it is formed, it will be deactivating the ring, because the ring has already positive charge. The electrophile needs 2 electrons, so it has to react with an electrophile, means the pyridine has to give 2 electrons, but since the nitrogen is having positive charge, it deactivates the ring. So hence you can say that pyridine is least reactive. Least reactive towards aromatic electrophilic substitution reaction. Okay, suppose if they are asking a question like this, so when you have some benzene, you have what you have here is you can have a simple, you can have a nitrobenzene, you have a simple benzene, you have something like pyridine here, and you have some compound like pyrrole. So if they are asking the SEAR, aromatic electrophilic substitution reactivity, so pyridine will be the least. So you have to know that it forms a complex, it deactivates the ring. So this will be the least reactive towards aromatic electrophilic substitution. You may be studying that nitrobenzene will be a least reactive. Even more least reactive, that is pyridine. So the pyridine will be the least reactive than nitrobenzene, and then comparatively benzene will be more reactive. And when you compare with benzene and pyrrole, pyrrole will be more reactive. So this type of question you may expect in part B of CSR question. Okay, right. So I have given you a few examples of this N electrophile substitution of pyrrole ring. So what is happening when you treat with the methyl iodide? Immediately it is attacking here, and it forms a corresponding N methylated product. Similarly, if you treat with the sulfur trioxide, it will be leading to the corresponding product. And if you treat with acid chloride, so this will be attacking here, this will be leaving. As a result, you will get N-acylated product. And if you treat with the corresponding nitronium ion, so this will be directly attacking here, and it will form this one. So that suppose you are saying that whenever you have pyridine, that nitrogen will be undergoing reaction with the electrophile. Then that is, you may ask a question. Then there is no reaction at the ring. If you ask, yes, there is possibility is there, but the possibility of reactions will be very less. You will get very less amount of product. But you must know where the reaction is taking place in the case of pyridine ring. So you know that this is pyridine ring. So the electrophile can approach the following position. So this is 1, 2, 3, 4, 5, 6. So you know that the 2 and 5 positions are same. Sorry, 2 and 6 positions are same. And then 3 and 5 positions are same. Then you have a fourth position. So the reaction may occur at C2 or C3 or C4. There are 3 possibilities at that. Where the reaction will be taking place, that is the next question. I would like to explain that. Suppose if the reaction is taking place at C2 position of pyridine. So what happens here? This electron will be attacking here, and if it is attacking means the positive charge will be generated. I think I'm sorry. So this is actually C3 position. I'm sorry. Yeah, C3 position of indole is reacting here. That means here I think you have to draw the structure like this. So both way that is correct. Say for example, if it is taking place at this position, the positive charge will be generated at C2 position. Okay, that is what happening here. Now this cation has to be stabilized by resonance effect. So if the resonance is taking place here, that is, this pi electron will be shifting over here, and as a result of this, a positive charge is generated at this position. Now this electron will be shifting here, the positive charge will be generated at this position. In these are the resonance form. So in all the resonance form, there is no positive charge formation on the nitrogen atom. So nitrogen is third most electronegative atom in the periodic table. If a negative charge is forming on nitrogen means it will be stable, but a positive charge is forming at nitrogen atom means it will destabilize the molecule. For example, next I would like to explain, this is a position, that is if the reaction is taking place at C2 position. C2 position means the electrophile is attacking at this position. Okay, so if C2 position is attacked, the positive charge will be generated at C4 position, C3 position. Now it has to be stabilized by resonance. So first, initially this pi electron will be moving here. As a result of this, you are getting a positive charge here. After which this pi electron will be shifting over here, and here you can check there is a positive charge formation on nitrogen atom. This is less stable. So the position of C2 attack will be ruled out. Now there is another possibility, that is C4 position attack. Suppose the attack is taking place at C4 position, the positive charge will be generated at C3 position. Okay, now immediately you have to think of the resonance form. The first, this pi electron will be moving here. After moving that, you are getting a positive charge on nitrogen. Since nitrogen is an electronegative atom, positive charge formation will be less favored. So this is less stable form. That means C4 position attack also ruled out. So the most reactive position in pyridine is, that is C3 position is most reactive. These two are less reactive. Okay, we must know that already the electrophilic substitution of pyridine itself is very less reactive. Among them, C3 position is more reactive. Okay, I have given you a few examples in this case. You can check here. This is a nitration of pyridine. So can you imagine the reaction? Can you check? So you are taking pyridine, you are treating concentrated nitric acid and concentrated sulfuric acid. You are heating the reaction at 300 degrees centigrade. 24 hours you are treating the reaction. But after 24 hours, The reaction is taking place at C3 position only. I agree, but you can check with the yield that is 6% only you are getting. Means it is almost negligible you are getting. So that is why I said already that pyridine electrophilic substitution will give you always very less amount of product. So what is that? How to overcome this negativity? How to overcome this drawback? If you ask, the only solution is you have to convert this pyridine into some other group, and after that you can carry out the reaction. Means you will get somewhat better yield. Say for example, in this case, this is like this compound name is colidine actually. That is 2,4,6-trimethyl-pyridine. This compound is having 3 activating group. Methyl is an electron donating group. That is 3 activating groups are present. Okay, so that means it gives more electron to the benzene, pyridine ring system. As a result of this, when this compound is treated with the nitric acid and oleum, so in this case you can check this nitrogen is protonated. After that, the nitration is taking place at C3 position. That is 1, 2, 3. 3 position the nitration is taking place. You can get the yield that is 90%. So direct nitration or direct electrophilic substitution of pyridine will always give you somewhat less amount of product only. Okay. We have an important reaction based on this nitration of pyridine. So how to increase the yield of the nitration? There is another way. Okay, so this is an important question. Please keep in mind. I think one time CSR they have asked the question. I will give you the CSR question after this completion of this pyridine reactions. Okay, what happens initially? You have to treat pyridine with a peracid. Okay, pyridine when you treat with peracid is an oxygen donor. So what happens? This lone pair attacks this oxygen atom and it provides you pyridine N oxide. So instead of this peracid, you can also use MCPBA. MCPBA itself a peracid. Instead of giving you a general name peracid, you can use MCPBA. So you can check with the formula that is RCOOH. That is RCO3H is present. So this is an oxygen donor. So instead of this peracid, they can also give you a carboxylic acid that is RCO2H and H2O2, hydrogen peroxide. So either this combination can be given or this combination can be given. So please keep in mind. So this is an important question. So this pyridine will be converted into pyridine N oxide. Oh, now this pyridine N oxide, when it is treated with an electrophile, it will be easily undergoing reaction. How? If you ask the question, I will give the explanation. This electron will be moving here. This electron will be moving here. That means this negative charge on oxygen atom is giving the electron to the pyridine ring system. As a result of this, this pi electron will be attacking here. You will be getting that 4 position substituted product. You have electrophile here. Double bond O, you have the substituted electrophile here. This is a product will be formed. That means the C4 position of pyridine will be undergoing reaction. So I have this complete mechanism in this case. You can check. When this N oxide is treated with nitric acid, concentrated nitric acid and concentrated sulfuric acid at 100 degree centigrade temperature, we know that the reactions of this nitric mixture will provide you the formation of nitronium ion. I already explained that C4 position will be attacking here. So this will be attacking here this nitronium ion, and as a result of this, the C3 position of this pyridine N oxide will be getting a positive charge. Once it is formed, this pi electron will be moving over here, and as a result of this, parallelly this oxygen lone pair, minus charge will be moving over here. So it will provide you the corresponding double bond formation. Now, final step is this hydrogen has to be leaving as H plus. So what is happening here? This electron, CH bonded electron will be shifting here. This will be coming here, and this will be moving here, and this electron will be moving over oxygen atom, and it provides you the corresponding aromatized product. That is 4-nitropyridine N oxide product will be formed. Now my aim is to remove this oxygen atom. My aim is to convert pyridine into 4-nitropyridine only. So I need to remove this oxygen atom. What is the method I have to use? So we know that in Wittig reaction, the byproduct will be triphenyl phosphine oxide. That means what is the information that is phosphorus has strong affinity towards oxygen atom. Okay, that is what is taking place. Now you need to remove this oxygen, means you have to use a phosphorus based reagent, that is you have to use triphenyl phosphate. It is not always necessary to use triphenyl phosphate. Any phosphorus based reagent you can try in this case. What is happening? This oxygen will be attacking the phosphorus atom, because phosphorus is having a d orbital, vacant d orbital will be there. So oxygen minus charge will be attacking the phosphorus atom. As a result, that oxygen phosphorus bond is taking place. Since phosphorus has accepted a pair of electron, negative charge is generated. Okay, so now what is happening? This minus charge will be moving over here. As a result, this oxygen nitrogen bond will be shifting towards the nitrogen atom. So it is broken here. You can check here. This oxygen nitrogen bond is broken, and this electron will be shifting towards nitrogen, and this positive charge become neutral. That is, the lone pair of electron on nitrogen has come back. So my aim is done. So that is, I have converted pyridine into 4-nitropyridine. So this is an important question. Just keep in mind. We have one more type of reaction, that is sulfonation of pyridine. I already explained that if you do the direct electrophilic substitution of pyridine, will always give you low yield. That is regular sulfonating agent. That is when pyridine is treated with oleum. That is, oleum is otherwise known as H2SO4 along with the SO3. That is fuming sulfuric acid. They may call. And if you treat this fuming sulfuric acid, will lead to low yield. That is, substitution will be taking place at C3 position. There is no doubt about that. But you will be getting low yield. So in order to overcome this drawback, you have to treat with the mercuric sulfate along with that sulfuric acid at 200 degrees centigrade. It will provide you a mercury-based intermediate. So what happens? Directly the reaction will be taking place at the formation of nitrogen-mercury bond formation will be taking place. And as a result of this sulfonyl group will be attacking at C3 position, and it will lead to the formation of 70% yield. That is, pyridine 3-sulfonic acid will be a product. Okay, so this reaction also a new one is important. Please keep in mind. Okay. Next, that is halogenation of pyridine. When you treat pyridine with the bromine along with oleum at 130 degree centigrade temperature, you are getting 86% of 3-bromo substituted pyridine system. Similarly, when you treat with when you want to do chlorination, you have to take chlorine along with that aluminum chloride. If you treat this compound at 100 degrees Celsius, you will be getting that 3-chloropyridine as a product. So these are the electrophilic substitution of this pyridine system. Next reaction, that is Birch reduction of pyridine. This is another important reaction. I think 2 times in CSR examination they have asked this question. When you treat with pyridine in sodium in liquid ammonia followed by the treatment with ethanol will give you 1,4-dihydropyridine. It is an important reaction, just keep in mind. So what initially happening in this reaction is sodium is 1 electron donor. When you treat with ammonia, it provides you electron. Okay, so this electron will be solvated by this ammonia molecule. So it provides you solvated electron, and sodium will be becoming Na plus. So now this electron will be reacting with pyridine. So what happens? This electron is coming here. This pi bond electron will be moving here. This electron will be moving here. This electron will be moving here, and this electron will be moving here. You have N minus, because nitrogen is giving one more electron. An electron is coming here. You have N minus. you have a radical here. Okay. Now this is protonated with ethanol. So N minus will become NH. You have a radical here. Now one more electron is coming from the sodium and it provides you an anion. Now treatment with ethanol will give you, it's a protic solvent. It takes hydrogen from ethanol. That is 1,4-dihydropyridine. That's a final product. So it's an important reaction. Let's keep in mind. Very famous reaction. Okay. Next reaction, that is nucleophilic substitution of pyridine. Okay. You must know that we have already discussed the electrophilic substitution of pyridine. Similar way, we have to discuss the nucleophilic substitution of pyridine also. Okay. So as usual, there are three possibilities. The reaction may take place at C2 position, or C3 position, or C4 position. When in this case, C2 position is undergoing reaction. When the nucleophile is approaching the C2 position of pyridine, the pi electron will be moving towards nitrogen atom. As a result, anion is generated. I have already explained nitrogen is a third most electronegative atom. A formation of anion on nitrogen will stabilize the system. Formation of cation on nitrogen will try to destabilize the system. Okay, so that means here the anion is forming on nitrogen atom. That means this anion is stable. Okay, so after which the following resonance structure will be taking place. Now the second possibility is, that is reaction at C3 position. Okay, you can take that a nucleophile is approaching the C3 position. As a result of this, the pi electron will be moving towards C4 position. Now, again, this is coming towards this carbon-carbon single bond. This pi electron will be moving towards here, and negative charge is generated here. Now, this electron is moving here. This pi electron will be moving here. Negative charge is generated. In all the resonating forms, there is no charge on this nitrogen atom. That means this attack at C3 position is less favored. This is less favored. Okay. What about that is final possibility, that is C4 position attack. So if the attack is taking place at C4 position, initially the attack is taking place, this electron will be moving here. And as a result, the electron will be coming here at the C3 position. Now this electron will be shifting towards this carbon-carbon single bond. This pi bond electron is moving towards a nitrogen atom. And in this case also, a negative charge is generated on nitrogen atom. So this resonating form is stable. Okay, that means nucleophilic attack on pyridine will be taking place at C2 position and C4 position. Both are possible, but C3 position attack is not possible. So that is a conclusion. Now, I will give you a few examples in this case. Now, what is happening when that pyridine is treated with phenyl lithium in diethyl ether as a solvent at 0 degree centigrade temperature? So, in this case, phenyl lithium will be separated at phenyl minus and lithium plus. Now, I already said the reaction will be taking place at C2 or C4 position. Now, the phenyl minus is attacking at C2 position, and this electron will be shifting towards nitrogen atom, and nitrogen is getting positive charge. We know that there is already hydrogen atom is present in the pyridine case. That is what mentioned here. And then the final step, what is happening in the presence of oxygen atom? So this electron will be coming here, and this part will be leaving. So hydride will be leaving. That means it will be combining with one more hydrogen, and it will be removed as hydrogen. That is, oxidation will be taking place in this reaction. Okay, so reaction is taking place at C2 position. There is one more example. This is well-known example. So you can use lithium amide, or you can also use sodamide. In this case, the NH2 minus will be attacking at C2 position of the pyridine ring, and as a result, this pi electron will be moving towards oxygen atom, leading to the formation of this anion. Now, this anion, once it is formed, this electron will be coming here, and this carbon-hydrogen bond, this hydride will be leaving as H minus and takes up one more proton from this another amide system, and it will be removed as hydrogen, and you will get 2-aminopyridine as a product. This is a very famous reaction, well-known reaction, that is known as Trichy reaction. You might have studied in your BSc itself or in MSc itself, you might have studied. Well-known reaction. So this also can be asked. Right. We have one more type of example that is also called as nucleophilic substitution of pyridine. Okay, you can check here. This compound is that is 3-chloropyridine, and this is 4-chloropyridine. So this is 4-chloropyridine. This is 3-chloropyridine. If you treat both compound with the sodamide, you can check here. This is also treated with sodamide. This is also treated with sodamide. Definitely, you may be thinking like Chichibabin type of reaction will be taking place here. You may be thinking, but actually, there is a formation of C4 amino group. That is 4-aminopyridine formation is there. That is major amount in both cases. And 3-aminopyridine also forming, that is minor product, that is 27%. That is the first formation of 4-amino product major and 3-amino product is minor. So it is not like going like addition elimination type of reaction. In this case, the first step is addition. Second step is elimination. Like Chichibabin type of mechanism is not taking place in this reaction. Then what is the mechanism that is what taking place? You may be thinking. I'll give you the explanation to this question. Actually, this is the first step. You can take here. You can check here. This amine takes this acidic hydrogen. It is like benzene type of mechanism will be taking place. Okay. What is happening? This amine takes this acidic hydrogen. As a result of this electron will be shifting here. This will be going. And similarly, if you check in the case of 3-chloropyridine, this amine taking this acidic hydrogen atom. Okay, and this electron will be shifting here, and this will be going. In both cases, you are getting that is same intermediate, that is 3-pyridine. So this is 1, 2, 3. The name is 3-pyridine. Now the possibility is the attack of NH2 group can take place at C3 position or C4 position. It is similar to that of benzene reaction only. Okay. So first step you can check with the minor product. So this NH2 group is attacking at C3 position. Immediately the electron will be moving towards C4 position. That is, you have to think this intermediate. C3 position attack is taking place. You will be getting negative charge at C4 position. Now, in the second case, the NH2 group is attacking here, and that is C4 position. Immediately the electron will be moving towards C3 position. You may be getting this kind of intermediate. Okay. Now the question is, which is more stable? I already said that nitrogen is more electronegative atom. That is, it is considered to be an electron withdrawing group. So this anion is close to this electron withdrawing group. That is, this is an electronegative atom. It will easily pull this electron towards itself by minus I effect. It is close to this electronegative atom, this anion. So this anion is more stabilized. Whereas in the case of this, at the top, if you check, the corresponding anion is formed. So in this case, the nitrogen is away from this anion, negative charge. So it will be slowly stabilized by minus I effect. So you can call it as this is less stable. Okay, so now this less stable anion will provide you minor product. This more stable anion will provide you major product. You can cross check with the thing. Now, so what is happening in the final step? That is, once the anion is formed, this anion will take this acidic hydrogen from ammonia, and as a result, this position is protonated. And here also, this anion is formed, and this will be reacting with this hydrogen atom of ammonia, and it will provide you the corresponding protonated product. So this is the thing that you like. So in 3-chloropyridine and 4-chloropyridine, if you treat both molecules separately with sodamide, it will lead to the formation of 4-aminopyridine as a major product and 3-aminopyridine as a minor product. And the reaction mechanism involves the formation of pyridine. And in this case, the first step is elimination addition. The first step is elimination. And the second step is addition. So in previously Chichibabin reaction, first step is addition, second step is elimination. In the case of pyridine kind of mechanism, first step is elimination, second step is addition. It may be asked in 2-mark question, just keep in mind. Okay. So with this I almost completed. I would like to discuss a few more questions based on this pyridine as a reactant. You can check this question was asked in December 2017 GSR examination. That is, pyridine is treated with hydrogen peroxide and acetic acid, followed by the treatment with nitric acid and sulfuric acid, is nitrating agent, followed by the treatment with PCl3. So I have already explained you the same reaction. When you treat pyridine with peracid or hydrogen peracid acid combination. And just before I have explained, that is, to formation of pyridine N oxide will be formed. This reaction, exactly this reaction only. So in this case, what is happening? When you treat hydrogen peroxide and acetic acid reagent combination with pyridine, pyridine will be converted into pyridine N oxide. Now, this pyridine N oxide is treated with concentrated nitric acid and concentrated sulfuric acid, that is nitrating mixture. It will be leading to the formation of 4-nitropyridine N oxide. That is, substitution will be taking place at 4th position. Now, this compound is treated with PCl3. I already explained you, instead of triphenyl phosphine, you can use any phosphorus-based reagent. That is, phosphine-based reagent you can use. But what happens? This phosphorus will be reacting here. So here the byproduct will be phosphorus double bond O Cl 3 times. So it will be leading to the formation of 4-nitropyridine. If you cross check with the option, that is option 2 is the right answer. Okay, just a 2-mark question. Right. Next question is this one. I think this question was asked, I think 4-mark. Okay. Anyways, whatever may be the mark, so we need to solve this question. So they are given you 3-chloropyridine, and it is treated with sodamide. What will be the product? So I already explained this mechanism just before with you all. Yeah, this is 3-chloropyridine. Now, when you treat with sodamide, what is happening? This Na plus and NH2 minus, this NH2 minus takes this acidic hydrogen atom, this electron will be moving over here, and this will be shifting, leading to the formation of 3-pyridine. In the second step, this NH2 minus is attacking a C4 position, then only the electron will be coming to at C3 position. So there is one possibility. What is the other possibility? When this NH2 minus is attacking at C3 position, the electron will be coming to C4 position. Okay, so this will be formed as major product. This will be formed as minor product. So that means you will be getting mixture of major and minor product. That is, you will be getting a mixture of C4 and C3 aminopyridine product. So what is the right answer if you ask? That is option 3 is the right answer. Okay, next question. Okay, next question is this one. The major product formed in the following reaction is, so they have given you a dihalo substituted pyridine system. So there are two possibilities. Either the chlorine can be removed of Cl minus, or bromine can be removed as Cl minus, Br minus. So initially what is happening, this NH2 group from methylamine, that is methylamine. So this lone pair will be attacking at C2 position of this one. So when it is attacking, this electron will be moving here. You have minus charge. Here you have Cl. Here you have the introduced NHMe group. So hydrogen from NH2 will be removed from as H plus. Okay, so here you have a bromine atom, here you have a methyl group. In the second step, what happens? This electron will be coming here, the Cl will be leaving as Cl minus. You have NH, CH3 group. Here you have methyl group, here you have bromine atom. Suppose this is one product. Suppose if it is reacting at the bromine containing atom, that is a C3 position. I already explained in the case of nucleophilic substitution of pyridine, the reaction will take place at C2 position or C4 position only. C3 position will be least reactive. I already explained. The same thing in what is happening here. The lone pair will be attacking here. This electron may go here. This electron may go here. Or it may come here. This may go here. In any cases, you will not get the negative charge on nitrogen atom. That means C2 position always more reactive. C3 position nucleophilic substitution of pyridine will not take place. That is, only the chlorine will be removed. So if you check with the option, that is option 4 is the right answer. Okay, fine. So we have one more question. This is also yet another simple question. So what is happening here? So pyridine is treated with methyl chloroformate. The reagent name is methyl chloroformate. What is happening? The nitrogen lone pair is attacking here. This will be going. I already explained you with acetylation of pyridine. N-acetylation of pyridine. Same kind of reactions taking place. So C double bond O, OMe will be there. Will be having positive charge. Now it is reacting with that carboxylic acid equivalent reagent. So this is diacetyl reagent is like carboxylic acid equivalent reagent. So what is happening here? So this dimethyl alkene will be there, OTMS trimethylsilane, and you have OTMS. What is happening? This line oxygen lone pair will be coming here. This will attack the C4 position of this N-oxide, that is pyridinium ion. It is not N-oxide, it is pyridinium ion. And this electron will be moving here. This will be moving here. As a result, if you check with the intermediate, you have C double bond O, OMe. You have a double bond. You have a double bond. Now, this carbon is connected to this pyridine ring system. So this is connected to the pyridine ring system. To that, you have two methyl group. You have C double bond O TMS. You have OTMS. Since this oxygen has donated a pair of electron, a positive charge is generated on oxygen atom. If you do hydrolysis, so this bond will be broken. So this is already a positive charge is there. So this will be broken. And similarly, here also will be broken. Here you have hydrogen, here you have OH group. And there is introduction of the carboxylic group will be coming. C double bond O, here OH, double bond, N, CO, O, Me. Okay, so if you cross check with the answer, that is option, what is the right answer? Option 1 is the right answer. Yeah, cross check. Fine. So one more question. This is actually sodium methoxide is treated. So you have two kinds of chlorine atom here. So there is chlorine atom with yellow in color and chlorine atom in orange in color. So which will be undergoing reaction? That is a question. So the sodium methoxide will be separated as Na plus and OMe minus. So there are two possibilities. Either this can attack here or this can attack here. So this orange color chlorine atom is flanked in between two nitrogen atoms. So what is happening here? This minus charge will be attacking here. And this is stabilized by this nitrogen atom also and this nitrogen atom. So the negative charge is stabilized by both nitrogen atom. So this attack at this position is more predominant. So it will be leading to the formation of that is option C as a product. Okay. Fine. So I think we have, almost running out of time. So this is very difficult to give the explanation to the question. But I would like to give a brief brief thing whatever happening here in this reaction. So what happened? So N-butyl lithium is a strong base. It deprotonates this acidic hydrogen here and deprotonates this acidic hydrogen also. So what happens here? You have NH minus here, you have CH2 minus here. Now this compound is treated with an ester. You have R, C, double bond O, O, E, T. So instead of thiophene, I'm just keeping R. So first step, what happens? This attacks here, and this group will be leaving. You have NH and C double bond O. Here you have R group, that is thiophene group. That is, you have CS2 minus. Now this is attacking here, and this electron will be shifting here. There is cyclization, cyclic formation, ring formation will be taking place. That is, here you have O minus. After protonation, it becomes OH. Here you have nitrogen atom, which is connected over here. You have R group. Now the removal of water will be taking place. Will lead to the formation of a pyrrole kind of ring. You have a removal of water molecule is taking place. So instead of R group, I'm just drawing the thiophene. The thiophene C3 position is connected here. So if you cross check with the answer, that is option 3 is the right answer to the question. So you can try the mechanism based on this basic explanation, right? Fine. So I would like to conclude my talk with this acknowledgement. I would like to thank the principal of DG Vaishnav College for organizing such a wonderful program in yet another year, actually. So there are plenty of responses for this national level CSR program workshop. This is because of their effort only. I think I also thank the head of the department of DG Vaishnav College. I thank personally the madam for this organizing such a wonderful program and giving me the opportunity to share my knowledge with the participants. I also thank the faculty members of this department, and especially I would like to thank Dr. Gopal Krishnan sir for calling me and organizing such a nice program. And I would like to thank the rest of the organizing committee of this program, and I would like to thank finally the participants of this program. Without your participation, nothing will be happening. And I hope I have delivered my best with you all. This is some part of the heterocyclic chemistry. There are plenty of things that you may be studying, but I feel that if you study these things, at least some few questions like 5 to 10 marks that you can expect in upcoming CSR and GATE examination. Okay, so thank you everyone for your kind attention. This is my YouTube channel, and if you want to know some more reactions or more update of from my side, you can follow this YouTube channel. Yeah, I'd like to thank you everyone. Yeah, if you have any questions, you can ask.
Sir?
Yeah.
Sir, can you explain the direction of dipole moment in heterocyclic rings, sir?
Actually, this is somewhat difficult to explain, but I would like to share the screen with you all. So I'll give the screen, but you can share with the participants because it takes some more time to explain the dipole moment of pyrrole, pyrrolidine, pyridine, piperidine ring system. So I'll give the things to you. You can share with the participants. Yeah.
Yes, sir. Sir,
Any other
what
things?
reactivity order of the heterocyclic ring as a dienophile in a Diels-Alder reaction, sir?
I will explain already in that last slide itself. I mean, last session itself. No, that furan is the most reactive. It is Diels-Alder reactivity. Furan is most reactive. After that, you have pyrrole. After which you have thiophene. Yeah, This is our. I have explained in the last session itself.
Yes, sir. Okay, sir.
Yeah, next.
Sir, in June 2018 CSIR paper, you had explained the reaction of pyrrole, sir. So there, BOC, that is an amine protecting group, is used, sir. Like, what is the purpose of using it, sir? What if we use bare pyrrole ring for the reaction? What difference does it make, sir?
Shall we start?
Sir, am I audible?
Yes, yes.
Sir, in June 2018 question paper of CSIR, sir, you explained the reaction of pyrrole. So there we
Just a
had
moment, just a moment, just a moment. Yeah.
Yes, sir.
June 2000.
18.
Pyrrole, yeah. Okay. Yes, I think this one. Yeah.
Yes, sir. So we are using BOC as amine protecting group. Like, what is
Yes.
the use or what is the purpose of using it, sir? What if we
Yeah.
use bare ring for this reaction? What difference does it make, sir?
I already explained you in the case of Diels-Alder reaction of pyrrole. I already said that the pyrrole is the nitrogen lone pair will be more contributed towards the aromatization of pyrrole ring. So that means this when the nitrogen lone pair is moving towards this, I mean double bond system, the diene will be disturbed. The position of this diene will be disturbed. Okay. So that means it is not a very good diene for Diels-Alder reaction. So suppose if I convert this NH into Bach protection, that is, you have to treat with Bach anhydride. So if you treat with this reagent, this will be protected. Sorry. So this is a structure of tertiary butoxy carbonate. Now, that means you are introducing an electron withdrawing. If C double bond O is attached to this nitrogen, that means basically you are converting an amine into amide. So what happens? This nitrogen lone pair will be moving towards the C double bond, right? So that means the involvement of this lone pair into pyrrole ring will be slightly reduced or 50% reduced. Now this diene will be perfect to undergo Diels-Alder reaction. That means the double bond will be less disturbed, very less, so that you can utilize as a perfect diene for Diels-Alder reaction. I hope you got my point.
Yes, sir. Thank you, sir.
Fine. Then any other question you have?
No, sir, no further questions, sir.
Sorry, no further question. Yeah. So
Yes.
thank you.
Sir, we have a vote of thanks, sir.
Yeah, please. I will be here.
Yes, sir. May I now request V. Swarnalakshmi of 2nd MSc Chemistry to deliver the vote of thanks for Dr. A.L. Muthukumar, sir.
Honorable Speaker of the session, respected Principal, Secretary, revered professors, and my dear participants, a warm good morning to everyone. It is indeed my pleasure and privilege to have been given the opportunity to propose the vote of thanks for this wonderful session. On behalf of the staff and student community of the Department of Chemistry, DG VAISHNAV College, I would like to express my sincere gratitude to our resource person, Dr. A.L. Muthukumar, Assistant Professor at Kurinji Arts and Science College, Trichy, for accepting our invitation and gracing the occasion despite his busy schedule. We are enlightened by your knowledge and intellect, sir. Your exemplary method of explaining the mechanisms, thereby tutoring the right manner of tackling tricky questions in heterocyclic chemistry, made us overcome the obscurities and difficulties in dealing with organic section. We'll definitely follow your instructions and guidelines and prepare ourselves accordingly while appearing for competitive exams in future, sir. Once again, I thank you for this mind-blowing session.
Yeah. Thank you so much for the management and the department so for giving me this opportunity. I hope the things whatever we have discussed in these sessions will be very much useful. Yeah. So thank you everyone.
Thank you, sir.
Yeah. May I leave?
Yes, sir.